Hey, hi everyone. So today we'll be looking at this problem subarray equals k. So what is the problem statement says that given an integer nums and a value k, we have to find how many subarrays exist such that the sum of those subarrays, the sum of that subarray is equal to this value. So for example, here we can see that there exists, this is a nums array and we have 1, 1, 1 and the sum value is 2. So basically we have two subarrays, this one with the sum of 2 and this one with the sum of 2, right? So let's get into it, right? So yeah, so we have two examples and we'll be taking these two examples for our consideration and try to come up with a solution. So firstly, if we talk about this solution, so uh, we have to find how many subarrays exist such that their sum is 3. So basically, this is one subarray. This is your another subarray, which has the sum of 3. So I can count 3, that I can count 2. There might be more, but what's the way to code these kind of problems? So if you have actually solved any of the sliding window problems, so uh, your mind might your mind might go to there that we can maintain two variables left and something's wrong with my laptop or what. So we can maintain two variables left and right and we can also maintain sum. So what we can do is while your sum is less than goal, you can include that value in your array and keep on increasing. And while this sum is lesser than goal, you'll keep on adding to your window. And if at any moment your sum becomes equal to goal, you will increase the count. And if sum actually becomes greater than goal at any point, you will uh, you will cut from the left and you will increase this L. But this approach is not actually going to work here, and we'll see why. So, what was the basis of our solution here is that if at any point your sum is, firstly take this case. So if at any point your sum is lesser than goal, you are going to include the element at the right position, and in this manner your sum is increasing. But here, since we are also having negative elements in the array, there is no guarantee that including your right value is actually going to increase your sum. Similarly, similarly for this case also, if the element at a of L is negative, then uh, then removing this element from left might actually lead to increase in sum. So due to these factors, your sliding window algorithm is going to fail here. So now that we know that the sliding window algorithm is going to fail here, so what is another approach that maybe we can come up with? And let's try and find another approach. So what we can do is, so maybe we can try and generate subsequences, but that is not going to help here because we need subarrays and subarrays need to be continuous, right? So what we can do, is there anything other than that that we can do is, so the core intuition behind this algorithm is if, let's say from left to right index, if the array has sum of x plus k from index L to R, and then it has sum of uh, let's say x from index L to I, then this naturally becomes your uh, k, right? So this is basic mathematics. From I plus 1th position to r, the sum is going to be 4. So what I'm going to, what I'm trying to say is, let's say we have this array 0, 1, 2, 4, and let's say minus 2. So the sum, so let's say if the sum from this position to this position is what? 4 plus 2, 6 plus 1, 7. And let's say the sum from this to this position is 1, then this two positions, the sum of array from this position to this position should be 6, right? So this is the core idea behind this algorithm. So, mm, so what are we trying to do is we have the sum of, we want to find how many subarrays are such that their sum is 3, right? So at any point, we'll try to see that. So we have come here, the sum is 7, right? So we will try to find 7 minus 3. Does there exist a subarray which has the sum of 4? If there exists a subarray which has sum of 4, then this space would naturally have a sum of 3, right? So this is what we are trying to do. All right. So this is the heart of the algorithm that we are going to be that we are going to design our solution around. Okay. So and also since we want the sum. So we'll be needing a data structure to store the sum. So for starting, let's just start with having a simple variable sum. So at the initial position, the sum is going to be 0. At index 0, the sum becomes 0. Here, sum becomes minus 1. So again, at this index, we are going to see that does the does the so for in here, the sum is 0. So we are going to see that if 0 minus 3 exists, right? So let's say the sum from here to here is 0. So what we are trying to do is that does there exist a subarray which has sum of minus 3? If there if there was a subarray with the sum minus 3, then naturally there would have been a subarray to counter it and make the sum to 0, right? So also, this should give us an idea of the kind of data structure that we want. Since we want to find that if there exists a subarray which has the given sum, so maybe a data structure like tree map or a tree set should do, right? So for starters, we'll just start with set, right? So this is going to be a prefix set, right? So let's say we have 0, we'll initiate the site with 0. Now again the 0 comes. So this is a bit problematic, but hey, let's we are trying to come up with something, right? So we'll just ignore this for the moment. Now minus 1 is coming up. So we'll see minus 1, minus 3. So does there exist a subarray which has sum of minus 4? If we can see very clearly there is no subarray yet with which has the sum of minus 4. But had there been a subarray which has sum of minus 4, which had occurred earlier, then this would have been sum of 3 because minus 4 plus 3 would have given us minus 1, right? So yeah, it's not present. So we'll move forward and we'll put this in our set. Now 2 and minus 1 is basically 1. So for 1, we'll check 1 minus 3. Does 1 minus 3 minus 2 exist or not? So had it existed, what would have happened? The sum from this index to this index would have been minus 2. And to counterbalance it, there should have been a subarray with the sum of 3, right? So in this manner, we can iterate this array and we'll try and find if there exists a subarray with the sum k, right? So let's move forward and try to see if the sum here is 4. For 4, what we are trying to do is for 4, we'll check if 4 minus 3, which is 1, does 1 exist in our set? So this is the first instance where we can see that yes, 1 in fact exists in our map. So what happens here? So the sum from 0 to this position is 4, and we see that the sum from this position to this position is 1, then naturally what that means is that the sum of array from I plus 1th index to this index should be 3. And let's try and check if that is the case or not. So the sum from this position to this position is 4, and the sum of this position to this position is 1. So that should leave us this element. And in fact, the sum of this subarray is 3, right? So we basically increase our count, and we'll soon enough we'll see that we have come across another problem. So now, what we're going to do is the sum here becomes 2. And for 2, what we're trying to do is 2 minus 1. Does minus 1 exist in our map or not? So, yes, it does. So, let's check for minus 1 also. So, for the sum from this position to this position is minus 1, and the sum from this position to this position is 2. So, that should leave us with this. So, 2, 3, and minus 2. So, yeah, in fact, the sum is uh, in fact, the sum is 3, right? And now we come here and we decrease the sum by 1, and we see that the sum here is 1, right? So now what we see is that the sum from this position to this position is 1. And sorry, we actually have to check. What we have to check is, does 1 minus 3 equals to minus 2 exist or not? So does minus 2 exist in our subarray? No, so it's not going to be there. But this example kind of leaves an edge case, which we will discuss with the help of this problem. But I hope so far what we have understood is that we are uh, using a data structure like a set to do these queries. M dot find sum minus k exist or not, right? And okay, so let's change the question here only, and then we'll see. So what should I change this value to? Okay, so if we change this to, okay, so let's try changing this position to 0. So we'll try to change this position to 2, right? So if we try minus 2, if we try to change this position to minus 2, the sum here becomes 0, right? So for false, give me a minute. Let's try and change this to 3, right? So the sum here becomes 1, right? And for 1, what we are going to do is अरे यार हद हो गई यार -2 हमें तो 1 चाहिए भाई. Okay, my bad. If the sum here is 3, so it becomes 5, right? So for 5, what we are going to do is we are going to check that if 2 exists in our hash map or not. So it does, right? And so what does it mean is that the sum from this position to this position is 2, and the sum from this position to this position is 5. And that means, so what I was trying to show you was duplicates, right? So I want 0 here. So where am I? if you put 1 here, so the sum becomes, yeah, so this is the right, okay. So if we put 1 here, so the sum here is 3. And for 3, what we are going to do is 3 minus 3 is 0. So what we are going to check is that does 0 occur in this array? And in fact, this does. So let's check. The sum of that element should be 3. So from here to here, the sum is 3. And from here to here, the sum is 0. So this array should be of sum 3, right? So let's check. Minus 2, 3 to 5, 5 minus 1, 4, 4 minus 2 is 2, plus 1 is 3. But we'll see, as we have seen very clearly, that if we include nothing also, there is the sum, I mean, the sum is 0. But if we take this element also, the sum is 0. So what I'm trying to say is from here to here, the sum is 0. From here to here, the sum is what, 3. So this should have the sum of 3. And minus 2 minus 1, 1 plus 3, 4, 4 minus 2 is 2 plus 1, 3. Yeah. So what I was trying to say is that if we are just taking set, we are essentially losing out on the solution. Why? Because there exists two arrays such that the sum is 3. There exists this array with the sum of 3, and there also exists this array with the sum of 3. So we can see that 0 essentially solves a purpose. So we are going to track how many times 0 has come up, right? So if we track how many times 0 has come up, and since we only want the count, so let's say 0 occurs 3 times. So from here to here 0 occurs, from here to here 0 occurs, and from here to here 0 occurs. And sum until this point is 3. So from here to here sum is 3, from here to here sum is 3, and from here to here also sum is 3. So essentially count, we'll be adding the count by m of that element, I mean the occurrence of that, right? So what we want is a data structure like a map which will solve our purpose, right? So essentially from array we have moved to set, and from set we have moved to unordered map, right? And in this manner we have come up, we have actually found what the data structure we want to store our prefix sum, right? So this is essentially the root of the problem. I hope you guys understood why we uh, use the unordered map here, and what it will store is that sum versus frequency. So our data, I mean our data structure unordered map will store these two pairs. All right, let's get into the coding part of this solution, and yeah, let's actually try and code this thing up. So the very first thing that I want to do for some reason is just try to extract the size of this array in n. And so what were all the things that we needed? So we needed a running sum, and what else? We needed a unordered map of integer m, which will basically store sum versus frequency, right? And anything else? I hope not, but let's see. Okay. So and yeah, so if you guys remember, we had actually initiated this thing in our solution, that the sum at the start of our loop is basically 0, and it has the occurrence of 1, right? So let's get into it. For auto a in a, sum plus equals to a, this gives us the running sum. And for every position, what we were going to do is we were going to find that if our sum minus k exists in the hash map. If it does, we were going to increase our count by m of sum minus k. So basically, if you remember the example of 0, so we had 3 instances of 0, and hence we were getting 3 subarrays with the sum k or 3. So m of sum minus k is basically it will give you the 0, and the when we try to reference it with this, it will actually give you the frequency of that sum minus k, and that is why we're doing that. And so, and I mean, if that sum minus k exists in our map, we are going to increase our count by that many times, the frequency of that element and all. And if, I mean, Also, we are going to increase the frequency of current sum. And once this loop has done, we are simply going to return this count variable. And let's try and run this the test cases. I hope all the test cases are going to pass. Okay, I might not have declared the count variable. Let's try now. Okay, so the test cases are passing. Let's try and submit this solution. So all the solutions are accepted. I mean, all the test cases are getting accepted. So now let's talk a bit about time complexity of this solution. So we have taken unordered map and we are going to iterate this array, and inside this array we are trying to find the element in the array. So this is a constant operation, and hence we are simply essentially just running a for loop, and this for loop will simply be O of n time. And about this space complexity, we are maintaining these two variables. This should be O of 1, but then again, we have unordered map. So the worst case is that we have all the elements stored in, I mean, let's say we have an array of 1500 elements and all those elements are unique. So essentially your hash map will also be order of n, and where n is basically the size of the array. So I hope you guys understood uh, first of all, why sliding window failed in this solution for this question, and why specifically we used a hash map, and also why we were using this combination like sum and the frequency. So I hope all of that made sense. If not, let me know, comment in the comment section and I'll be happy to reply. So yeah, thank you guys and keep watching. Thank you.